Hello everyone. In this topic, we'll discuss about how Docker images work. We will see what is the difference between software packages, operating system, and the Docker container itself to understand what operating system on the host is going to do and the container which is running on the host operating system, how it is going to function. Let us see these actions one by one. Software packaged into a container. Software packaged as a container, the container image which we are going to deploy. So we have the container image which we are going to use to run our containers is not limited to application only which developer is going to build. So we have the developer who is going to write the code, and this particular container which we are building from this image, it is not limited to the application code itself. We need to have the application code. We need to have system package. We need to have binaries. We also need to have libraries, and we need to have config files and any other dependencies which the application requires. In this example, we are going to build order tracking portal for our company's various outlet to use. For our order tracking portal for our company, the requirement is to build our application stack using container image. The stack will be, we need to get the base image, and we need to have the proxy, which is Nginx proxy server. So this will be the proxy server, and we need to have the application code itself. So this is the software package which we are going to build, and this will be built as an image. Once the image is built, we will run the containers. So we can run multiple containers out of this image. So all of these software components, which are application code, Nginx, which is acting as a reverse proxy server, and the base image, which will be Ubuntu server. So this will be the container image. And using this container image, we are going to build our company's order tracking portal. Let us see what is container image. Image is a portable package which contains all the software components which are required to run the application. So these software components will be the application code, the libraries, the binary configuration, and if there is any mapping, that also we need to use in the container image. So these mappings can be to the network and to the storage volumes. It is the image when it is run becomes our container. So this will become as the software package using which we will be able to create the image. When this image is run, this will be our container with all the application code and its dependencies put together is an image. The container, whatever we are running on the host operating system, is simply in-memory instance of the image. So this container is simply an in-memory instance of image. This is why we will be able to run multiple containers out of the same image. So each container is just a in-memory instance of the image. The image is immutable. Once you have built an image, you can't change it. So once you have used all the necessary files to build the image, you will not be able to modify or change this particular image. If you wanted to change, or if you wanted to add, let us say if you have mapped 80 to 80 port number, and if you wanted to change the image to 80 to 80, This will be the port mapping, which is inside the image using the mapping. And if you wanted to map instead of your local volumes, if you wanted to map the storage to connect to cloud file servers, then you have to change the config file within the image. Then you are going to add the layers on top of the existing image, which is going to change the image. With the changes, whatever you have done to your file to create an image, you will not be able to update the same image. You need to use another image with the new changes. So this will be your new image. You can make this image as version 1 and this image as version 2, which will have all these new settings. An image can be as small as BusyBox image or Alpine image, or it can be toned down version of Nginx, Ubuntu, or MySQL images. There are plenty of images which are available in the Docker Hub, which we will be able to use to run our containers. So what is host operating system? Host operating system is where the Docker engine is running. Docker engine contains the Docker server and Docker API and Docker client. This is Docker engine. Docker containers running on Linux share the host operating system kernel and doesn't require a container operating system. So container operating system is basically when you wanted to package your image using the another layer of operating system. This is Ubuntu operating system. So this is another layer on top of which you wanted to install your Python runtime and your application code. If you are running on Linux host operating system, this layer is not required. You can build your image using only the application code, Python, and the dependencies. You will be able to run the containers. These containers, which are deployed on host, which has Linux as the operating system, can access the kernel directly. So this layer is not required. So we are going to eliminate this layer whenever we are using the Linux as the host operating system. However, Windows container need a container operating system. The container depends on the operating system kernel to manage services such as file system, network management, and process scheduling, and memory management. In this example, we see the host operating system is a Windows-based host operating system, because of which we wanted to have the container operating system as the Ubuntu Linux. It can be any other flavor of Linux, but we need to have container operating system on top of which we are going to build our dependencies and the application code itself. So this is the application and any other dependencies for that application to run. The containers, whatever we are going to run on top of this image, cannot directly access the host OS kernel, which is Windows host OS kernel. We need to use the Linux kernel. Via the Linux kernel, we are able to talk to the host OS kernel to talk to the services such as file system and the network services. The container operating system is the operating system that is part of the packaged image. In this example, we have the Ubuntu. So this is the container operating system, on top of which we have our, it can be Nginx, it can be our application code, and this is packaged with the container operating system. The container operating system is isolated from the host operating system. The container operating system in this case is Ubuntu Linux. the host operating system is Windows operating system. Both are isolated, and the image what we are going to use to build our containers, even if we take the image to run the containers on the development or the production, this image will be same. So this is the image which we are going to use across our multiple environments, which can be in development or production. We use the same image across different environments. We have many file systems. We have NTFS for Windows. We have ext, ext2, ext3, ext4 for Linux, and we have also RiserFS for Linux again, and we also have XFS. So these file systems are used by the host operating system to create and manage the files and directories. So we can use these file system to create and manage files and directories on the disk. So once we have formatted the Windows operating system with the NTFS file system, we will be able to store the files onto the disk using the NTFS file system. Similarly, for Linux, it can be ext or RiserFS or XFS. We will be able to store the files and directories onto the disk once we have formatted the disk with the proper file system. Similarly, for Docker images, we use UnionFS file system to create the Docker images. UnionFS is a file system that will allow us to stack several directories which are called as branches in such a way that it appears as if the content is merged. The top layer, whatever you are seeing, it is the writable layer for the container. And all these layers are read-only layers. Whatever containers we are going to deploy on top of this image, let us say we are going to deploy many containers out of this image. The topmost layer of this image is the read-write area, which all these containers use to read and write the data. So what is base image? Base image is the image which you are going to start to build your container image. So this will be your base image. So this is the starting of the image layer which you are going to build. So this base image can be scratch image, which doesn't contain any container operating system. And on top of this, you are going to build your layer. So whenever you build your images, you will start with the from. So this will be your base image. If I am starting with Ubuntu, then this is my base image. If I start from Flask, this is my base image. If I am using Scratch as the base image, then I have direct access to the host operating system kernel. So this is my host operating system and this is my kernel. If I am selecting the Scratch as the base image, I'll be directly able to access the host operating system kernel because this Scratch image doesn't create the file system layer, and we'll be able to directly access the host operating system kernel. And you might be wondering, what are these? These are the text entries which you are going to write inside the Docker file. So Docker file is used to build the images. So we need to write whatever images we wanted to deploy on our environment. Everything we need to specify in the Docker file to build the images. We need to start with the from to build our images. Then we need to add multiple lines which are required for the software packages. So what is parent image? Parent image is a container image from which we are going to create our images. So we will start with the parent image and we are going to create multiple layers which is required for our software package. And in total, this is the image which we are going to use to run the containers. So where we are going to specify all these entries, these are basically the text entries. Each text entries or text lines which are specified in the Docker file is going to create and package the image.